Today we are going to derive an important equation from the chapter current electricity. We're going to derive the relation between current and drift velocity. So now we have two terms, current and drift velocity. We need to know the basic formula for current and velocity. Okay, so what is that? So we have I is equals to Q by T. This is the one of the key point in this derivation, and the second key point is V is equals to displacement by time. So distance or displacement by time we can have as a key point. Okay, the two formula as a key point, it is one is this one and this one. Now let us understand this derivation. For that we need a conductor. This is the conductor we have here. Okay, and that is connected to a battery here. So this is the positive terminal of a battery, this is the negative terminal of the battery. So let us understand the conductor. So here the geometrical shape of the conductor is the length of the conductor is given as L and area of the conductor is given as A. Okay, so area of cross section also we can say these are the area of the conductor. Now you can see in every conductor there are so many number of free electrons. Okay, these free electrons will be in motion. Okay, so how it is moving from a negative terminal of a battery towards a positive terminal of a battery. All the free electrons will be moving from a negative terminal of a battery towards a positive terminal of a battery. So this is the direction where the electrons will be moving. Now, so what is the direction of current here? The direction of current will be opposite to the direction of electron movement or moving. Okay, so that you need to know. So this is what we have understood from the diagram. So that we are going to write as a description of the diagram. So how we are going to write? So look at here. So consider a conductor of length L and area of cross section A containing n number of free electrons. That means, so at this area we have n number of free electrons. Okay, so now I want to know how many number of free electrons are present in complete volume. So what I do, let us see now. Okay, so let us know what is the volume of it. Volume is area into length. Okay, so if I multiply area and length, I'll get complete volume of this conductor. Okay, then so I need to know what is the number of free electron present in this volume. Okay, so what I do, how many number of electrons are present in this entire conductor? That means, so I know how many number of electrons are there in this area, so multiplied by this length. That means simply multiply n into the volume. Okay, that is n into A multiplied by length. That is what we have. This AL is nothing but volume. Just remember as n into the volume that we have. A into L is a volume. The total charge in a conductor, that means each electron carries a charge that is represented by E. So the total charge in a conductor that is represented by or given as n is equals to, that complete charge is NEA into L. Okay, so that is represented by Q. The total charge is represented by Q is equals to NEAL. Okay, so now we know the basic formula, that is I is equals to Q by T. Just substitute what is Q that we have obtained from this equation, that is Q is equals to NEAL. So simply just substitute it. So I is equals to NEAL divided by T. So that is what we have as an equation 1. Now second key point, that is a second formula, that is V is equals to displacement by time or distance by time. The distance, what it represent, the electron will move from one end to other end. Okay, that is the distance we have. Okay, or distance or displacement we can have. So the complete length, okay, where the electrons moving from one end to other end, that is represented by L. So that is L we have taken here, and the time that is taken by electron to move from one end to other end is T that we have taken. So it is L by T. So Vd is nothing but a drift velocity of an electrons. Okay, that we are going to represent. Now I want to know what is the T here. Okay, so because we need to substitute here. Okay, that is why we are deriving for T. So T is equals to L by Vd. So that is what we get as a equation 2. So now substitute the value of T in the equation 1. Okay, substituting equation 2 in 1. That is what we have here. I is equals to NEAL divided by L by Vd. So what get cancelled here? L and L will get cancelled. Vd will go to the numerator. So there we get a final equation, that is I is equals to NEAVd. Okay, thank you.